Hello, today I built this. It's a Raspberry Pi Pico W with a potentiometer connected to it. It reads the signal coming from the potentiometer. We need a micro USB cable, the Pico W with a development board or a proto board, a grow cable and the potentiometer of course. Then we connect the potentiometer with the grow cable to the ADC1 socket. It's the pin number 27. Then we connect the Pico W to our PC, or in my case my laptop, and then we're ready to code. From the machine library I import the pin and ADC functions and use them as shown here. Take connection to the pin number 27, and then there's three options for the LED to blink. When the voltage is at its max, the LED blinks every other second. And when the voltage is 0 or 0.2 in my case, because the reading wouldn't go so low, the LED stays on, and if it's anything in between that, blinks every third second. And here's just a demonstration of that. But now for the good thing, the refactoring part of this video. Okay, so I'll be going through this program a little bit later when I add comments to it, but now I'll just rename this the ADC, and that's the signal coming from the potentiometer. Then we define the ADC max, which is 3.3 volts, because I convert the 16-bit signal that the ADC function reads to a range from 0 to 3.3, and then we get the delay by dividing the ADC reading with the maximum voltage to get a value between 0 and 1, and that's the delay in seconds. Then I'll get rid of these options. So the time.sleep function is needed for the LED to blink. And here I'm adding the delay as the parameter, so the LED blinks in sync with the reading. And here I'll show you. This program is much better because the LED actually is much more in sync with the potentiometer voltage, and it doesn't have only 3 options. So basically in this program we connect to the LED with the pin function and writing a string led.pinout. Inside of that, the pinout is meaning pin output. Then we save it to the variable, and the potentiometer reading we'll be getting with the ADC function and the pin function combined, and then we give it the pin number 27. Make sure you check out what your pin number is. It can be 26, 27 or 28, as there's 3 ADC pins in the Pico. Then we convert the 16-bit reading with the conversion factor of 3.3 volts, and then we get the 16-bit signal read from the ADC and convert that. Thanks for watching. Bye bye. Hello. Today we'll be